Hello. It is time for a supplemental homework assignment that goes with the last recording I just made for the results section. I talked about what goes into a results section, about figures and tables. I talked about statistical analyses and what types of statistics. And I know there were words like inferential statistics and things like that that may be a little confusing. So I'm going to try and go over it all with you. I have a PDF here that you guys can see, which is a little bit lopsided because it was scanned at a weird angle, I guess. And I realized that this format of the PDF, which I will include in the materials, is unable to be edited. So I made an edited version of it, which is over here, as you can see. And so I can kind of go back and forth with it. There's also some statistics that need to be done here that I was able to print out a statistical program that's actually free online, but you guys, as I promised at the beginning, don't have to do any of the statistics. So I'm just here to explain them to you, and hopefully you can fill this out. There will be an answer key with this afterwards. So without further ado, I think, why don't we go ahead and go over this hypothetical experiment, and I will talk through what needs to be done. And this will be due in about a week, so a week from tomorrow. We talked about the results section. Now we need to calculate some statistics and figure out how to make a results section. So the homework here of this factorial design and analysis exercise is basically I have put together a sort of fill in the blank, kind of like a Mad Libs. Is basically just have to fill it out. So let's go over the study. Let's look at the numbers and see if we can at least partially understand how exactly you fill this out. Here's the bonus part of this. When it comes time to do the results section for our own analysis, for our own final papers, you can actually use the results and the answers from this assignment to use this document as a template to help to write your final paper. Now, of course, we're not using these same categories, and the numbers obviously won't be the same, but the way that you put the numbers in, what means go where, how can we tell when one is higher than another, this is the sort of thing that you can use as your template when we figure out and fill out the last portion for this class, which is for the final paper. So, the results section. Will the depth to which information is processed affect how well it can be remembered? And if so, would such an effect depend on the type of automation being processed? To address these questions, suppose that we conducted the following experiment. Well, we see that there's two different questions here. The depth to which information is processed, does it affect how well it's remembered? And would this effect depend? Remember in chapter 12, we talked about how it depends is sort of a giveaway for a factorial design. Well, if information is processed on two levels, does that depend on how it's being processed? In this case, it seems pretty obvious that we're running a factorial design. So, in order to answer these questions, you constructed 4 sets of stimuli. 2 sets, A1 and A2, we'll call them, each contain 20 printed words that are the names of common concrete objects. And 2 other sets, called B1 and B2, each contain 20 line drawings that depict the same objects as named by the words in sets A1 and A2. So half of the sets are words describing what the things are. So maybe it would be like a picture of we'll say chair. So in sets A1 and A2, the word chair would be printed out, CHAIR. And in set B1 or B2, the word chair would be in the actual drawing of a chair. So we have words and we have drawings. That's two levels of one IV. And they depict the exact same objects as named by the words in A1 and A2. Thus, in total, you've constructed 80 stimuli. You have 40 words, 20 in A1 and 20 in A2, and you have 40 line drawings, 20 in B1 and 20 in B2. All the words and drawings are the same. So 40 words and 40 drawings of those words. All right, hopefully you're still with me. Next, you presented 40 of those stimuli in random order to each of 10 subjects. Half of the 10 subjects received the 20 words from set A1 and 20 drawings from set B2. The other half received 20 words from set A2 and 20 drawings from set B1. Thus, although no one subject received a word and drawing depicting the same object, right? These participants either get the word chair or the drawing of a chair, but they don't get both. So although one subject received a word and drawing depicting the same object, across subjects, the presented words and drawings depicted the same object. So some participants saw the drawing of a chair, the other half would only see the word chair, so to speak. So for each item presented, you instructed the subjects to write down either the number of syllables in the item's name, which is what we call acoustic processing. So the word chair would only have one syllable. Or you asked them to indicate as an answer whether the item was animate or inanimate, which is what we call semantic processing. Semantic means understanding the context based on understanding based on the context of the words around it. So if I were to say, Barney went to go sit in a chair, and then the word chair, you ask, is that animate or inanimate? Well, because it's not a living thing, it would be an inanimate object. So you would write down an A, or I don't know why it says 9. I'm going to change this really quick to an I. Oops, document encountered an error. Whatever that's. Oh, come back to me, please. Come back to me. Well, that's not good, is it? All right, well, it's coming back. Okay. A little magic trick there for you. Don't try this at home, folks. So, going back to it, for each item presented, you instructed the subjects to write down the number of syllables in the item's name, acoustic processing, or to indicate whether the item was animate or inanimate by writing down an A or an I, respectively. In fact, if I change this over here, we can do this one better. Okay, we're right here. How each item was to be processed was indicated by a cue occurring just before its presentation, and you distributed 2 types of cues evenly throughout the series of 40 items, making sure that each subject was cued to process 10 words and 10 drawings to an acoustic level, asking the number of syllables, and 10 words and 10 drawings to a semantic level, animate or inanimate. Furthermore, across subjects, you counterbalanced which words and which drawings were processed to acoustic and semantic levels so that at the end of the study, each word and drawing had been processed to each level an equal number of times. So let's stop there and analyze for a second. Remember, we talked about in a between subject or independent groups design, each subject or participant only participates in one group and not all of them. In that one, we don't have order effects. We have selection effects, which, again, if we go back to chapters 10 and 11, we talked about. And those selection effects were counteracted, mitigated, whatever word you want to use, stopped, prevented by either match design or random assignment. In a within subjects design, we don't worry about that because basically everybody does everything. So you serve as your own control, right? Um, but for that one, that's the one that's subjected to order effects. And what did we say when we did a within subjects design for the Stroop task? We counterbalanced to control for order effects. So remember that sometimes keywords can sort of give away what's going on. We in this study, it was shown in a very wordy way that each subject did 40 words, 20 semantic, 20 acoustic, blah, 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 blah. So in a roundabout way, we can say, oh yeah, well, it looks like each participant participated in each group. But the easy way to pick this out as we're going through it is you saw the word counterbalanced. So right away, if a experiment is counterbalanced, that is a really fast shortcut to know that it is a within subjects design because it's counterbalanced. Could it be a mixed design and one of the um, independent variables is within and you would still use counterbalancing? Probably, but again, I'm not trying to trick you, so this isn't going to get that deep. All right, so across subjects, you counterbalanced which words and which drawings were processed to the acoustic and semantic level, so that at the end of the study, each word and drawing have been processed to each level an equal number of times. So, moving on. All items were presented at a 5-second rate, which means 5 seconds between questions or words or drawings. And after the last item's presentation, you had the subjects perform a 2-minute filler task. Maybe you gave them a word search, a crossword puzzle to do. And after 2 minutes time, this is so they wouldn't just keep the words in their head, in their working memory. It's a distractor task or a filler task so that their brain isn't concentrating on the words or pictures they just saw. And then, of course, you give them a surprise recall test on which they were to write down the names of as many of the items presented in the preceding series as they could recall. Table 1, remember a table is the one that has all the numbers. So table 1 presents the number of items recalled by each subject in each condition. So we're going to have 4 numbers. We have 4 basic cells, right? In a 2x2 design, we're going to have 2 levels of one IV and 2 levels of another IV. And just kind of like the homework in chapter 12, you have two levels of type of processing. We have acoustic, in which they're asked how many syllables, and we have semantic, in which they're asked, is it animate or inanimate? And then we have the items themselves. We call this item type, and it's either words or it's drawings, right? So it's either the word chair, C-H-A-I-R, or it's a drawing of a chair, which gives us 4 groups. We have acoustic words, acoustic drawings, semantic words, and semantic drawings. We have 10 subjects for this. Obviously, we would do more than 10. We did do 10 for the Stroop task to make it easier, but we also want to make sure that I want to make sure you get the understanding of what the numbers mean. So your dependent variable is the number of items that were correct. So how many syllables the word had, or how many, whether the object is animate or inanimate. Any combination of those right is given a point. So these are the numbers that they got. Remember that there were 10 in each group. So each subject, numbers 1 through 10, had all 4 types of group, right? So what we see here is acoustic words, acoustic drawings, semantic words, and semantic drawings. Subject number 1 got 8 correct for acoustic words, 10 correct for acoustic drawings, 8 correct for semantic words, and 10 correct for semantic drawings, and so on and so on and so on. So what we have here for 10 subjects is 4 scores for each subject for each of those groups. And these are the numbers here: 8, 4, 6, 7, 2, 8, 3, 4, 5, 4, 10, 9, 10, 8, 7, 9, 10, 9, 7, 10, etc., etc., etc. So these are the raw scores. These are the scores that each individual person got for each um, specific category here. Now, what we're going to do for this um, assignment is, first of all, we need to find out what these numbers mean, and we need to put them in a meaningful way, which I've already done for the most part. Um, so for this, the question that first comes up is, from the data displayed in Table 1, compute the cell means and the marginal means and enter them in the appropriate spaces below. Now, there is a space for standard deviations from the original document that I took this from, but for the purposes of this class, we are not going to worry about the standard deviations here. I will show you that the analysis is already done on another page. Up here it says Vassar stats. So if I were to click on that, you'll see something that it's kind of hard to decipher, and I need to go all the way back up to the top. I should just use the little bar and go up to the top. So basically, the type of design with a factorial design, the type of statistical analysis we use is what's called a two-way ANOVA, and ANOVA stands for analysis of variance. We're looking at the variance of all the groups. So basically, what I wanted to show you was that I took these numbers up here, whoop, 8, 4, 6, 7, 2, 8, 3, 4, 5, 4, right? And I entered them separately into each group. So we have A1, B1, we have A1, B2. Down here we have A2, B1, and A2, B2, right? So going back and looking, the first row, we would call this A1, B1, acoustic words, 8, 4, 6, 7, 2, 8, 3, 4, 5, 4, right? Going to the statistics, I entered them exactly like that, 8, 4, 6, 7, 2, 8, 3, 4, 5, 4. The next one, the next group, 10, 9, 10, 8, 7, right? So this would be A1, B1, and this would be A1, B2. So looking at it, 10, 9, 10, 8, 7, 9, 10, 9, 7, 10. Looking down here, I'm sorry, here we go, A1, B2. 10, 9, 10, 8, 7, 9, 10, 9, 7, 10. And I did the same thing for the other two rows. Remember that our statistics, when we point them out, we usually use group means, which is the average of each of these groups. So basically, for these four groups, A1, B1, A1, B2, A2, B1, and A2, B2, we calculated the means for each group. But the nice thing about a statistical program is it not only compares the means, but it also gives you a bunch of the other statistics. We call them descriptive or inferential statistics, right? Descriptive statistics would give you things like, here's the number of people per group. So we had 40 people. We had 10 subjects, and all of them did all four of these, right? So we have A1, B1, A1, B2, A2, B1, A2, B2, 10, 10, 10, and 10. So this just tells us how many people competed or how many scores were computed for each group. 10 per group, number of subjects 10, each subject did 4 measures, right? Looking down here, this is going to tell us what our means are. So this says means for cells, rows, columns, and totals. So we have the 4 main means here, and then on the sides, I've given you the marginal means. And I will remind you how to get those. So going back here to this, we look down below and it says, factorial design analysis exercise. From the data displayed in Table 1, compute cell means and marginal means and enter them in the appropriate spaces. So again, I'm not worrying about standard deviations. We're not going to deal with that. Number 1 on this exercise says, what are the 4 means and what are the marginal means? So here and here would be the marginal means for acoustic and semantic. Words and line drawings would be over here. So let's go over that really quick. And let me go back to this document, which is basically the same thing as this one, except it's now edited for you guys to be able to fill in. So I went ahead and on the second page, here's Table 1. I gave you guys, it looks a little crooked, but then again, it looked crooked on the PDF. So here is the same numbers for you. When entered right, the next here's your exercise. I gave you exactly what I told you I would. So here is the answer. So if we go back to this document and we're looking for the numbers to fill in the boxes, we have acoustic words, we have semantic words, we have acoustic line drawings, and semantic line drawings here, right? And then the marginal means for words and line drawings, the marginal means for acoustic and semantic. I will go over what they mean. Looking at these, we have 5.1 for acoustic words, 7.6 is the mean for acoustic drawings, semantic words is 8.9, semantic drawings is 9. Now, a reminder for the marginal means. The marginal means are for main effects, and the main effects are the levels of one IV, almost as if, or basically as if, the other IV didn't even exist. So if we're only looking at acoustic and semantic, and word and drawing don't even exist, what we're going to do is take both of these numbers for acoustic, and we're going to average them to give us our marginal mean for acoustic. So if you add 5.1 and 7.6, the answer is going to be 12.7. And you divide that by two scores, the average or marginal mean for acoustic is 6.35. For semantic, 8.9 and 9, right in between that is 8.95, or you could say 17.9 divided by 2. So acoustic overall, as if item type, word or drawing didn't exist, is 6.35 versus 8.95. You would probably say that, yes, that's a significant main effect. On the bottom side, it's words and drawings, as if acoustic and semantic didn't ever exist. So we take 5.1 and 8.9. If you add those two together, it's 14. You divide by 2. Your marginal mean for words overall is 7. For drawing, 7.6 and 9 gives you 16.6. You divide that by 2, 8.3. Hopefully you guys are still with me. So here is the 4 cell means: 5.1, 7.6, 8.9, and 9. Acoustic and semantic overall, their marginal means to compare for the main effect, and the marginal means to compare for the main effect. But of course, as we talked about in chapter 12, main effects are great and all. That tells us one level is higher than another. But the really important thing is the interaction, right? Does one of the IVs depend on the other IV? Is there an interaction? We talked about 2 ways to find an interaction: by looking at a graph, which we don't have here, or to look at maybe simple differences. Again, we don't have to worry about that, because one of the things that really tells us is the actual statistical tests. So let's get back to this page. This is the one that I asked you guys to fill out, and look, I did it for you. You're welcome. Acoustic words has an average of 5.1 correct answers, semantic 7.6, acoustic drawings 8.9, semantic drawings 9, and I gave you those marginal means just like I did for the Vassar Stats page. By the way, vassarstats.net, I think it is the statistical test, or the statistics website, so you can do this for free without a statistical program. You don't need to, but I'm just letting you know. So again, I already gave you the answer for number 1. You're welcome. Based on this design in the present experiment, what is the appropriate statistical analysis to use? Remember what I said at the beginning of this lecture. If not, you can rewind and go back. But I will remind you again that if you have I'll go over it really quickly. If you have 2 means to compare, if we were only comparing N and I, like the Stroop task, then you would only do a t-test. A t-test is to compare 2 group means. If you had 3 means or more, you would use what's called an ANOVA, or analysis of variance. So the t-test gives you a t-value. When we talked about a correlation, we talked about an R value, right? Lowercase r, meaning relationship. For an IV with 3 or more levels, or more than 1 IV, you're going to run what we call an ANOVA. Now, if you only have one independent variable, we call it a one-way ANOVA. In this case, how many independent variables do we have? I'll give you a hint. Acoustic and semantic is one. Drawing and words, or words and drawings, is another. We have two ANOVAs. And there is an ANOVA that is calculated for a between subjects or independent groups design. And there's another ANOVA that is calculated for the within subjects type of design. Sometimes it's called repeated measures. Based on the appropriate number of variables and the type of design that it is, the appropriate statistical analysis to use is, it's not a one-way ANOVA, we'd call it a two-way, and it's not between subjects, it is a within subjects, right? So two-way within subjects ANOVA, A-N-O-V-A. Number 3 says, using the data displayed in Table 1, conduct the appropriate analysis and complete the source table below. So if I go back to Vasterstats really quick, I want to show you guys that the ANOVA summary, we have 2 rows and 2 columns. Here's 2 columns, here's 2 rows. It is a 2 by 2 analysis. Again, we're looking at a within subjects design. So remember what we talked about in chapter 12. If you have 2 independent variables, you're going to have 2 main effects, one for each independent variable. You're also going to have, the most important one is an interaction to see if there is a difference in the differences, or if item type and type of processing have an interaction with each other. So what this tells me is you're going to get, in this ANOVA table, and I guess I can just scroll down, you will get, and here it is, within subjects, we have 3 hypotheses, and so we have 3 outputs. Here is item type, here, and its error term. Here's type of processing, and its error term. And here is item times processing, which just basically is a fancier way of saying interaction and its error term. Now, I want to point out that if we were doing a between subjects design, the error term would be the same for all 3. Because it is a within subjects design, you have an error here, 1.0667, here 3.2111, here 0.7889. So you have a different error term for each of the effects that we're looking at. In this table, which is something you may have never seen before, and in fact in SPSS or those, it looks similar to this, but not exactly like it. So what we see here is for the ANOVA, right, we talked about a t-test having a t-value. We talked about correlations having an r-value. Well, ANOVA has what we call an f-value. You guys should be familiar with the p-value. Significance for a p-value is anything that's less than 0.05. That tells us that there's less than a 5% chance that the scores we got were by random mistake or error. So we have the item type, right, which is word or drawing. We have the processing type, which is acoustic or semantic, and we have the combination of them, which we call the interaction. Sum of squares, SS stands for sum of squares. We don't really need to worry about that. I didn't want to cross it out though. The ones that we are worrying about are DF, which stands for degrees of freedom, MS, which is the mean square. We're really dealing with mean square of error, MSE. The F value itself, which is the numbers here, here, and here. And of course, ye old p-value, which if it's significant, you would know because it's less than 0.05 in these columns, or in these areas, down this column. So we will have a main effect of item type. This will tell us if we have a significant main effect. Instead of just looking at the because it's one thing to look um, at the means or marginal means to tell us, yeah, it kind of looks like it, 8.95 versus 6.35. This one is, 2.6 higher than this one. Um, Probably a, good indication that it's um, a main effect. But we need to know by looking at the p-value. 7 and 8.3. Well, 7 and 8.3, there's only a difference of 1.3. Is that significant enough to be a difference? Well, that's what the statistics will tell us. So, looking here, going down to number 3, we have this same, basically, table. Does that mean that you can just pretty much copy it over? Well, yes, actually it does. So, let me just go through what everything means, and then you know that for number 3, it should be pretty easy because I'm giving you this document as well, and you can just literally copy it down the way that it says. So let me explain what some of these things mean. All right, going to item type. We are looking at the two marginal means for item type. Now you see this thing that says degrees of freedom. Degrees of freedom is a term, if you don't remember from statistics, that tells you the number of groups and the number of subjects and sort of compares them. So we always talk about degrees of freedom being n minus 1 or number minus 1. So for item type, there were 2 levels, right? Words and drawings. So if we were looking at degrees of freedom for the number of levels, n minus 1 or 2 minus 1 is 1. For error, we had 10 subjects per group. So 10, n minus 1, 10 minus 1 is 9. So your degrees of freedom are going to be 1 and 9 for this F-test. For the numbers that we report the mean square of error, because what we get from the sum of squares divided by the degrees of freedom is our mean square. When we divide our mean square by our error, mean square error, that gives us our F value. So our mean square is 67.6. If you divide that by 1.0667, you will get 21.052. So the F value here for item type is 21.052, right? And here is the p-value. Remember, for the p-value, as long as it's less than 0.05, and sometimes it's even better if we report it as less than 0.01, because that tells us less than 1% chance that the numbers we got were because of some random error. So here we see the p-value at 0.001312. So what we would say about this is our p-value is less than 0.01. Or if you just want to be conservative, you can say less than 0.05. For type of processing, acoustic versus semantic, when you put them together, you have, again, degrees of freedom. Your F value is 1 and 9, because, again, 2 types of processing, so n minus 1 is 1. 10 people per group, n minus 1. 10 minus 1 is 9. We have 16.9. Oh, whoops. That's what I forgot to do. Let's change that really quick. What do you have? 1.0667. 3.2111. Whoop. 1.0667. See, as we do it. That makes much more sense. 67.6 divided by 3.2111 is 21.052. Now I see where the error was. 16.9 divided by 1.0667 is going to give you 15.8433. So F of degrees of freedom 1 and 9 is 21.052. Your mean square error, 3.21. Your p-value less than 0.05 or less than 0.01. For type of processing, we have F of 1 and 9 equals 15.84. Your MSE, or mean square error, is 1.0667. And boom, what we see here is that your p-value is less than 0.01. So that tells us, yes, we have a significant main effective type of processing. What about for the interaction? Well, here we see 14.4, right? Again, f of 1 and 9, because you have two IVs, minus 1 for the interaction is 1. 10 people per group, so 9. Here's 14.4 is your mean square. If you divide that by 0.7889 mean square error, you get 18.2533. And your p-value, 0.002073. So once again, p is less than 0.01. So we seem to have a significant main effective item type, a significant main effective type of processing, and a significant interaction, which for doing an analysis like this is something that we want. All right, so if we were to go back, here we see degrees of freedom, item type, 1 and 9, your mean square, and your mean square error here. F value for item type, you wouldn't have an F or P value for the error, right? So F value, your P value, and you can literally just copy it over from this. Type of processing, same thing, degrees of freedom 1 and 9. You're going to have your mean square and your mean square of error. If you divide the mean square by the mean square error, that gives you your F value. And so your F value is here, and your P value, which will be less than 0.01. For the interaction, degrees of freedom 1 and 9, mean square error. Here's your F value for the interaction. And what you will see, again, is 0.002073, so less than 0.01, and we have everything significant. So once you finish filling that out, then you have all the numbers you need. Up here, going up, this is taking a long time. This is the numbers you need for the means. So you have the means of each of cell. These are what we call the cell means, 5.1, 7.6, 8.9, and 9. And here we have the marginal means, which are for the main effects, 6.35, 8.95, 7, and 8.3. And if we were to go down from there, based on the following information displayed in the source table, remember that P is less than 0.01, we see, do we have a significant main effective item type? What would you say? Significant main effective type of processing? What would you say? Significant interaction between the two? What would you say? So, I would say yes, yes, and yes. I'm just saying. So, going down, for this portion of the assignment, you are to fill in the blanks provided here for the format of a results section. So what I did here, just to show you, is I gave you in parentheses, it says figure 1 presents the average, and this was blank. And the blank underneath it, it says description of the DV. So what were we measuring? What's the DV? What would you call it? How would you define it? Description of the DV, when they were presented in the form of one level of item type IV, what were the two item types? Words and drawings. So you put one item here versus the other item or other level. And as a function of the way in which they were processed. Looking at the patterns displayed in, what did we have up top? Did we have figure, a table? What was it called? Obviously, here it already shows you it's figure 1. So I'm guessing you know what to put here, right? See above? Oh, boom. It appears that items in general, this is our main effect, were better recalled when presented in the form of what than when presented as what. So if we're talking about items, there were only two levels. There was words and drawings. Which one, and if we go either back up here, right, or if we went here to Vassar stats, we could see words, drawings down here, acoustic semantic over here. So which one's higher, right? Now let me go back to the actual PDF. This is what the actual PDF looked like, which I couldn't recreate, even though I tried. You can see that there was another question here, but I'm not worrying about that. It has to do with post-tests. We're not calculating any of that stuff. So here's the exercise. This is what it looked like originally. This was the results section. Figure 1 presents the average, and here says description of DV when they were processed in the form of one level of item type IV versus other level of item type IV. and as a function of the way in which they were processed. Looking at the pattern of results displayed in uh, 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 it appears that items in general were better recalled when in the form of whichever one was higher than when presented in the form of whichever one was lower, and that they were better recalled when processed which way, acoustic or semantically, whichever one had the highest number first, rather than this would be the second level, the lower level of whatever was scored. So again, if we're playing at home, looking at the marginal means, this is for the main effects. So it looks like that items were recalled better in the form of drawings than words, and semantically more than acoustically. You see how I did that, right? The higher number gets mentioned first. So that's all I did there. Let's go back. The degree to which recall was affected by type of processing. So now we're talking about the interaction. How do I know? Look for words like it depends. The degree to which recall was affected by type of processing, however, appears to depend on the form in which the items to be recalled were presented. More specifically, when items were presented as, so one level of item type, type of processing appeared to have had a large effect. So if we're looking at marginal means again, there's a large effect here, right? Between when they were processed acoustically, we see a big difference, 7.6 and 5.1. Going back. It appears to have had a large effect on later recall. Whereas when those items were presented as oh, I see, it's words and drawings. So yeah, when they were presented as one, we see a bigger effect. When they were presented as another, we see a smaller effect, right? So, yeah, when processed one way rather than another. Type of processing appears to have had little or no effect between those two, whether it was acoustic or semantically. So again, looking acoustic and semantically, we see a big effect here, and we see a smaller effect here, 8.9 and 9, right? So fill that in appropriately. To test these apparent effects, data were analyzed using what kind of statistical test? Well, it's the one that you answered for number 2. So something about a 2 ANOVA within something like that, which revealed a significant main effect of, what's the first main effect? Well, it looks like we talked about type of processing or item type, right? So what words around here would tell us which one we're looking at, such that the average recall was slightly higher when items were processed. So was it item type or type of processing? Here, this would be the levels of type of processing, right? So which ones were higher? For type of processing, acoustic and semantic. Look at the marginal means, semantic more than acoustic, right? So if we go back to this, to test these apparent effects, the data were analyzed using that type of statistical test. There was a significant main effect of type of processing, such that the average correct recall was higher when the items were processed. What does it say? Semantically, right? And then you see M and SD. We're not worrying about standard deviation, but M is the mean. In this case, if we're looking at a main effect, our mean is the marginal mean, so 8.95, right? And, 8.95, then when processed, what would that be? Semantically, and what's the mean there? Regardless of the form in which they were presented. Remember when I talked about a main effect, I talked about it as two levels of the IV being compared to each other as if the other IV didn't even count. So acoustic and semantic, regardless of the form in which they were presented. So lines and drawings doesn't matter here. Here's our F value. We have our degrees of freedom. Remember, it was 1 and 9. Here, what was our F value? What was our mean square error? And the P value. Remember, when we put P, we're not going to put the actual value. We're just going to put less than or greater than, right? So less than 0.05, or if you want to get really specific, less than 0.01. What was the other main effect that we found? We found a significant main effect of item type, which was also revealed, such as the average recall was significantly higher when items were presented as, well, it's either going to be words or line drawings. Here's the mean, and what's the lower one? There's the mean, regardless of the way. Here's the F value, 1 in 9. F value, mean square error, P value. Additionally, there was an apparent interaction between type of, what is it, processing and item type, that is indicated, was also revealed to be significant. So here, the F value, degrees of freedom, F value, mean square error, and P value for the interaction, which is right here, right? Item by processing interaction. You'll find everything you need here, 1 in 9, F value, mean square error, P value, right? So you fill those in. Then, in contrast, wait, so let's see. All right, so that brings us to basically right here. Now, down here, I already filled this one in for you on the other sheet. It's multiple comparisons. And the reason that we sort of skipped a little bit, but what we would do is what an ANOVA tells us is an ANOVA tells us that there is a difference between at least 2 of the groups. Here we have 4 groups, so we're comparing all 4 of them. And you don't need to completely get this, but I just want to show you when we're looking at the interaction, we're comparing all 4 groups. And so we have to make individual comparisons because the ANOVA doesn't tell us where the difference is, it just says there is a difference. It could be a difference between 1 and 2, 1 and 3, 1 and 4, 2 and 3, 3 and 4, right? We don't know where that is. So we would make what we call individual comparisons. Now, I'm not going to ask you guys to do that, but it will tell you to compare the cell means instead of the marginal means. So here, individual with multiple tests or multiple comparisons with a Bonferroni correction. You don't need to know what that is, but basically, if you're making multiple comparisons, it doesn't necessarily keep alpha at 0.05, which is what we want. So this Bonferroni correction does that. Again, you don't need to know what that is. When presented as words, we're looking at the average recall for items was revealed to be higher when they were processed where. So if we go back here, this is where we use the cell means. When they're processed as words, which one was higher? Semantically was higher, more recalled than acoustically in words. Semantically was also higher in drawings. So that's where we would fill in these means, the cell means, and not the marginal means. So looking here, right, you're going to see that it was significantly higher processed to a semantic level. What's the mean here? Then when they were processed to an acoustic level, what's the mean there? We skip the t-value parts, and I'll show you on the next one. In contrast, when presented as line drawings, the difference in recall were processed to, and again, I believe it was semantic higher than acoustic, and then you again put the mean there, and we're not talking about doing this. And the rest of it, I'm not worrying about. So if we go back to the actual one that you guys are filling out, we go down here, you can see that figure 1 presents the average. So everywhere here in parentheses where it says description of the DV, you're simply going to erase it or just fill in the right thing. Number of blah, blah, blah. So I'm going to go back and keep it the way it is. Oops, going back up. And basically what I'm asking you to do is fill out the blanks. I'm going to give you the PDF version so you can see what it looks like. But basically all you got to do is erase all of these parentheses and put in the appropriate wording and numbers for the means. So if I were to go down like I promised you, you can see here is an F, degrees of freedom of the IV, degrees of freedom of the error, 1 in 9, equals whatever the F value is of this IV Here's the mean square error of the error of this IV, and the p-value. P is less than, again, we would put 0.05 or 0.01. Significant main effect, so it looks just like this PDF, only in a way that you can actually fill it out. Right? So I will provide all three of these files for you, the original PDF, the stats that you can use to fill in, and then the sheet that you fill in everything, and this is the one that you'll turn in when it's done. If there are any questions, you can always email me. Otherwise, or show up to office hours next week. This will be due next Sunday the 10th, a week from tomorrow. And that's about it. So I will put this up as soon as it's ready, and I will speak to you